Alright, now we're going to start talking about the sum to product formulas. So if we go back to our formula sheet here, and if you want a copy of this, check the video description. There's a link in there. You can click that link, open this up, print it out, and follow along if you'd like. So the sum to product formulas are here, right next to the product to sum formulas. So these four formulas here, we're going to establish these in this video. And we're going to start with this one up here. Sine alpha plus sine of beta equals 2 sine alpha plus beta over 2 times cosine of alpha minus beta over 2. And these four here, well, first of all, this one up here, we can get this one from this third product of sum formula here. Okay. And then the second one's going to follow from an algebraic manipulation of the first one, and then this third and fourth we're going to get from some of these other ones here. Okay, so let's start with this first one here. So what we're going to do is, it's going to involve something kind of weird, so what we have to do is rewrite this one, but instead of alphas and betas, I'm going to use x's and y's, because we're going to make a little substitution, and then we're going to rewrite something in terms of alphas and betas, and then we'll end up with something over here. Okay, so sine alpha cosine beta is 1/2 of sine alpha plus beta plus sine alpha minus beta. I want to rewrite that with x's and y's instead of alphas and betas. So then what we have is sine of x cosine of y equals 1/2 times the quantity sine of x plus y plus sine of x minus y. Alright, now why am I doing that? Well, because here what we eventually want to have is some formula for sine of alpha plus sine of beta. Okay, so here's a sine of something plus a sine of something else. So what I'm going to do is take this thing here, I'm going to call it alpha. I'm going to take this thing in here, I'm going to call it beta. Okay, so in other words, alpha equals x plus y, and then beta equals x minus y. Okay. Now what we have here is a system of two equations with two variables, technically speaking anyway. So alpha and beta, and x and y. So our variables can be thought of as x and y. It doesn't really matter. We don't want to get that detailed about it. But what we can do then is solve this system of equations for x and y. So we know that alpha is x plus y, beta is x minus y. But how do we express x and y in terms of alpha and beta? That's the idea here. Okay, so basically to establish these sum to product formulas, what we do is we take the product to sum formulas, rewrite, instead of using alphas and betas, we use x's and y's, and then we make this substitution. Let's just call this whole thing alpha, we'll call this whole thing beta, and then we'll express everything in terms of alphas and betas instead of x's and y's. Okay, so now what we can do here, a lot of different ways to solve this system of two equations, but it's fairly straightforward, fairly simple. So what we can do is just add up both the equations. So then we have alpha plus beta equals x plus y plus x minus y. Okay, so add up the left-hand sides and then separately add up the right-hand sides. So alpha plus beta, and then on the right-hand sides x plus y, and then plus x minus y. So then what that tells us is alpha plus beta equals x plus y plus x minus y. So plus y minus y, that cancels. X plus x is 2x. So then we can divide everything by 2. So then alpha plus beta over 2 equals x. Okay? And so if we add these equations together, then we get x. Now that we have x, we can plug that back into here to get y. Or we could say, okay, what if we subtract the equations? If we subtract the equations, then we can also get y that way. But let's go ahead and do that. So we'll subtract the equations. So let's rewrite them. Alpha equals x plus y, beta equals x minus y. So now if we subtract the equations, then we'll have alpha minus beta on the left-hand side, and then on the right-hand side, zoom in a little bit, we'll have x plus y, and then minus the whole thing, x minus y. Okay, so it's this whole first equation minus the whole second equation. So it's the entire right-hand side on the top minus the entire right-hand side on the bottom here. Okay. So x plus y minus the quantity x minus y. So that means alpha minus beta equals x plus y minus, distribute the minus sign, so we have minus x plus y. Okay, so x blah 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 minus x, so those cancel. Then we have plus y, so alpha minus beta equals 2y. That's great, now we can divide everything by 2. So then alpha minus beta over 2 equals y. Okay, so that's what we have here. So x is alpha plus beta over 2, y is alpha minus beta over 2. So now we can use that to rewrite everything now in this equation, everything now in this formula in terms of alphas and betas. Okay, so let's go ahead and do that. So then what we have is a sine of, now remember x is alpha plus beta over 2, we found out earlier. Alpha plus beta over 2. And then y is alpha minus beta over 2. Okay, and then what we have is that equals 1/2 times sine of, remember x plus y, that is just alpha, that's how we defined alpha to be. And then x minus y is beta, that's just how we define it to be. Okay. So that's what we have there, and now let's multiply both sides by 2, and then we'll swap the sides. So remember, left side equals the right side. It doesn't matter which side we put down first, so let's just write the side over here first. So, and also multiply everything by 2. So when we do that, we're going to end up with just sine of alpha plus sine of beta equals 2 times sine of alpha plus beta over 2 times the cosine of alpha minus beta over 2. Okay, and that's our first formula here. So if we look here, sine of alpha plus sine of beta, that equals 2 times sine of alpha plus beta over 2 times the cosine of alpha minus beta over 2. Okay, so that's exactly what we have here. So that establishes this first formula here. Okay. Now again, why did we do that? It's kind of goofy, but what we did is we took our product to sum formula, and instead of using alphas and betas there, we wrote it in terms of x and y. Why do we do that? Well, because we want to eventually get the sum to product formula, and we want that to be expressed in terms of alphas and betas. So since we want to use alphas and betas for this, the sum to product formula, we have to use something else to start with the product to sum formulas. Okay, so that's why we used x's and y's. We can really use anything else we want here, just not alpha and not beta. Okay, so then once we use our x and y's or whatever else we want to use, then we say, okay, I want eventually sine of alpha plus sine of beta, so let me take this expression in here and call it alpha. Let me take this expression in here and call it beta. This is what I get. Alpha equals x plus y, beta equals x minus y. Now that's a system of two equations, in technically speaking, two variables, x and y. So I can solve this for x and y in terms of alpha and beta. Okay, and then we get x equals alpha plus beta over 2, y equals alpha minus beta over 2, and then we could use that, those two facts, to express this formula, this product to sum formula, in terms of alphas and betas. And then when we do that and manipulate a little bit, rewrite, we end up with a sum to product formula. Okay, so that's what happened there. Now that established this first formula. Using the second formula, we can do something kind of similar. Or to get the second formula, we can do something kind of similar, or we can just use odd properties of the sine function. So remember, sine is an odd function, so what that means is that sine of negative beta equals negative sine of beta. Okay, so how's that useful for us? Well, we can actually use it going the other way, and so instead of using it like to make this look like this, we can make something like this look like that. So specifically, let's erase this and make some room. So now we want to get a formula for sine of alpha minus sine of beta. Okay. Well, using the odd properties, we know that negative sine of beta equals sine of negative beta, right? Because sine is an odd function, so we know that's true. So sine of alpha minus sine of beta is actually sine of alpha plus sine of negative beta. Okay. Because this minus sign, we don't have a minus sign out there anymore, so it's really just like a plus sign. So negative sine of beta is the positive sine of negative beta, okay? So sine alpha minus sine beta is sine alpha plus sine of negative beta, because sine is an odd function. That's the only reason why, really. Okay. Now we can just use this formula right here directly. We can just directly use this, where instead of beta, we have negative beta. But it's still totally, completely fine to use that, because it's the sine of something plus the sine of something else. Okay, that's what this formula lets us do. Okay, so then using that formula, it's going to be 2 times the sine of alpha. Now instead of a plus beta, we have a minus beta, so it's going to be alpha plus negative beta, okay, over 2, and then times the cosine of alpha minus negative beta over 2. Okay, so then we can simplify a little more, and this is going to be 2 times the sine of alpha plus negative beta is just alpha minus beta. We have that over 2. And then cosine of alpha minus negative beta That's alpha plus beta, all divided by 2. Okay, and that's pretty much it. Sine alpha minus sine beta equals 2 sine alpha minus beta over 2 times the cosine of alpha plus beta over 2. And if we go back to our formula sheet, we see that that is exactly what we have right here. Sine of alpha minus beta is 2 sine alpha minus beta over 2 times the cosine of alpha plus beta over 2. Okay? So that established the second formula right here. Okay, now again, just to recap what happened real quick, we used the fact that sine is an odd function, so we can take negative sine of beta and rewrite it as plus sine of negative beta. And then we can use the sum to product formula that we already established. Sine of something plus the sine of something else equals this mess here. And we just applied this formula to this expression. Okay, so it's really exactly the same, except instead of a beta, we have a negative beta. So here's a beta, and instead of that beta, we have a negative beta. Okay? So just to kind of highlight that, here's our beta, but here it's a negative beta. Okay, because of this negative beta right here. Okay, here's our beta, alpha minus beta, but here's alpha minus negative beta, because of our negative beta right here. Okay, so here, beta, 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 negative beta, negative beta, negative beta. And then we simplified a little bit, and then we got our second sum to product formula. Okay, so that's those first two. Now let's go ahead and get to the third and the fourth. So we're pretty much going to do it the same way. But just to be thorough, we'll go through the details. Okay, so what did we do so far? So far we used this third product to sum formula to get the first sum to product formula. We could have used this fourth one here to get the second sum to product formula, but instead of doing that, we just used the odd property of sine, of the sine function. Now what we're going to do is use this cosine x, or cosine alpha cosine beta formula to get one of our other. Basically, we're just going to use these last two, or these first two product to sum formulas to get the other two sum to product formulas. So, and we're going to do the exact same thing we did. We're going to use x's and y's instead because we're actually going to go through the exact same process here. And that's also why I didn't erase any of this, because it's going to be exactly the same. We're going to do literally exactly the same thing, just with a different formula. So let's go ahead and do that. Okay, so let's use this product of sum formula. Cosine alpha cosine beta is 1/2 cosine alpha minus beta plus cosine alpha plus beta. But instead of alphas and betas, again, let's use x's and y's. So that's going to be cosine x cosine y equals 1/2 times cosine of x minus y plus cosine of x plus y. Okay. Okay, so then now we can just make those substitutions again. So last time we said alpha is x plus y, beta is x minus y. So let's go ahead and do that again. So notice they're actually in a different order now, so we should be a little careful about that. But anyway, here's alpha, it's x plus y. Here's beta, x minus y. Okay, so alpha is x plus y, beta is x minus y. All of this stuff is literally exactly the same. We end up with x is alpha plus beta over 2, and y is alpha minus beta over 2. Okay, so we still end up with all that same stuff, exactly the same stuff there. So let's go ahead and go through with that and see what happens. So we're going to end up with cosine of what's x? X is alpha plus beta over 2. And then cosine of y, what's y? Y is alpha minus beta over 2. Equals 1/2 times, what do we have here? Cosine of beta plus cosine of alpha. Okay. Now it's actually sort of customary to write the alpha part first, so what we're going to do is say, well, first let's do a few things at once here. So first let's multiply everything by 2. So what we're going to have then, let's just do that in this step here. So if we multiply both sides by 2, then that 1/2 goes away, this 2 comes over here, and then let's write the right-hand side on the left. So remember, left side equals right side. It doesn't matter which side you put down first. So then we'll say cosine of alpha plus cosine of beta equals 2 cosine of alpha plus beta over 2 times the cosine of alpha minus beta over 2. Okay. And here, cosine beta plus cosine alpha plus cosine beta, if you add two things together, it doesn't matter which order you add them in, so that's all that's happening here. Okay, so if we go back to our formula sheet, we'll see here, cosine alpha plus cosine beta equals 2 cosine alpha plus beta over 2 times cosine of alpha minus beta over 2. And we see that's exactly what we have right here. Okay, so that's our third sum to product formula. So we've just established that. Okay, now we have to get our fourth one here. So the fourth one's going to be cosine alpha minus cosine beta, but since cosine is an even function, we can't do the same thing that we did before. So before we were able to use the fact that sine of negative beta equals negative sine of beta. Okay, but the problem here is cosine of negative beta just plain old equals cosine of beta. Okay, so there's actually nothing we can do with this, if we want cosine alpha minus cosine beta. Okay, there's nothing that we can do with minus cosine of beta. There's nothing we can do with that minus sign, so we just have to approach it as a new thing from scratch, like we've been doing. Okay. So let's go ahead and use this sine alpha sine beta formula. We're going to use that one there. That's the one we're going to use. All right, now we are going to do that one a little bit differently, actually. So. And it might seem kind of tricky, but it's actually good to see it done in a slightly different way. Actually, we're going to do it pretty much the same way, but alpha and beta are going to represent the other things. So anyway, here we have sine of alpha sine of beta equals 1/2 cosine alpha minus beta minus cosine alpha plus beta. Okay. So we're going to do this with x's and y's instead of alphas and betas. So sine of x sine of y equals 1/2 times the quantity cosine of x minus y minus cosine of x plus y. Okay, so that's what we have there. Okay, now actually, you know what? Let's let alpha and beta still be the same things. All right, we'll just let alpha still be x plus y. We'll let beta still be x minus y. We could do it the other way around, but let's not cause unnecessary complications here. So anyway, alpha is x plus y, so here's our alpha. Beta is x minus y. Okay, so all of this stuff stays exactly the same, literally exactly the same. Not one single thing over here changes. So we still have alpha is x plus y, beta is x minus y. Then that gives us x equals alpha plus beta over 2, y equals alpha minus beta over 2. So we'll express this in terms of that. So then what we have is sine of x, which becomes sine of alpha plus beta over 2, times the sine of y, which is sine of alpha minus beta over 2, equals 1/2 times the quantity cosine of beta minus cosine of alpha. Okay, now here it's going to be a little trickier because what we really want, what do we want? We want this fourth formula here, which is something cosine alpha minus cosine beta. We don't quite have that. We have cosine beta minus cosine alpha. So we will have to do one extra step here, so we'll be a little more careful with all of our details. So first, let's swap the sides. Okay, so remember, left side equals right side. It doesn't matter which side you write down first. So we'll just swap the right and left sides, and that's always totally fine to do that. Sine of alpha minus beta over 2. Okay, so all we did here was just rewrite this equation with the sides swapped. That's totally fine. Now let's multiply both sides by 2. So then we have cosine of beta minus cosine of alpha equals 2 times the sine of alpha plus beta over 2 times the sine of alpha minus beta over 2. Okay, now we're almost there. There's just a couple more tiny little things to do. So first of all, cosine of beta minus cosine of alpha. Okay, that's, you know what, let's write this separately with a separate color down here. Cosine of beta minus cosine of alpha. That is the same thing as negative cosine of alpha plus cosine of beta. Okay, so this thing minus that is negative that plus this. Okay, so cosine beta minus cosine alpha is minus cosine alpha plus cosine beta. Now if we factor out a minus sign here, or factor out a -1 technically speaking, then we have minus the quantity cosine alpha minus cosine beta, which is exactly what we want to have eventually, right? So eventually we want to have cosine alpha minus cosine beta, so that's why we're doing what we're doing here, okay? So cosine beta minus cosine alpha equals negative cosine alpha minus cosine beta, there, that quantity, okay? So let's go ahead and write that. Negative quantity cosine alpha minus cosine beta equals all the same stuff on the right hand side, nothing changes over there. Okay, these goofy looking things are supposed to be betas. So 2 sine alpha plus beta over 2 times the sine of alpha minus beta over 2. Okay, now we don't really need this anymore. Now the very last thing left to do is to divide everything by -1. If we divide, or multiply really, depending on how you want to think about it. But if we divide or multiply everything by -1, then this negative sign goes away and comes over here. So then what we have is cosine alpha minus cosine beta equals -2 times the sine of alpha plus beta over 2 times the sine of alpha minus beta over 2. And that's our fourth formula. Okay, so again, we had a minus sign out here from cosine beta minus cosine alpha. We can rewrite that as negative quantity cosine alpha minus cosine beta. So then we want to get this minus sign away from here, so we can divide or multiply everything by -1. Okay, so then when we do that, this 2 becomes a -2, and that's pretty much it. And this is our formula right here. Okay, cos alpha minus cos beta equals this whole mess right here, -2 sine alpha plus beta over 2 times the sine of alpha minus beta over 2. And if we go back to our formula sheet, we see that that's exactly what we have here for the sum to product formula. Cosine alpha minus cosine beta is -2 sine alpha minus beta over 2 times sine of alpha plus beta over 2. So it's actually, they're switched around. This one is written first, but it doesn't matter, okay, because here you're just multiplying this sine function by this sine function, so it does not matter which one you write down first. So this is exactly the same thing as this sum to product formula right here. And that establishes that fourth one, and that's it for the sum to product formulas.